So just FYI. Just FYI, our exam opens up on the 2nd, 11 a.m. and ends up on the 4th, 10 p.m.
Well,
this week.
2 days.
At least it doesn't have to go in the same week as my other exam, my economics exam. So, okay, let me go to my homework. So, so number 3.
Okay, so in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. And that is true.
True. Number 4 is the last two, bottom one, the second and third. Okay. Construct a QQ plot for each group.
Yeah.
So you assume the variance of each group is the same if the following happens.
The largest variance is less than 4 times
The smallest variance.
smallest variance.
Oh my goodness.
Wait, so that's for it's the 4 times, not the 2 times?
It was 4 times, wasn't it?
Yeah, it's 4 times.
Okay, sorry, that's my bad. When it came to that one, I was confused.
So, number 7.
So connecting an impedance to 3 samples that are 3 pairs.
I put 4.
1, 2, 1, 3, 2, 3.
I
Well,
think it's 4 on that one also.
Okay, Sam.
Is it asking if we were doing t-tests, how many pairs would there be?
It's just asking how many pairs are there when there are 4 samples.
Isn't there 6?
Yeah, I think there's going to be more.
You pair 1 with 2, 1 with 3, 1 with 4, 2 with 3, 2 with 4, and 3 with 4. That would be 6.
Oh, that's true. So it would definitely be more than 4.
I think there's 6, right?
I think so, yeah.
Okay, let me check my. Okay.
What's the Excel calculator thing called? What's the file called?
It's the quantitative inference pro.
Oh, there it is. Procedures.
Procedures, yes.
Yeah.
I'm gonna, by the way, and I'm happy to send this to you guys as well, but I was gonna tweak this a little bit and have it automatically calculate things like
No error.
Yeah, the error, and then also if you should reject or not reject the sample.
I wouldn't mind a copy.
Okay.
Yep.
I'll tweak it and send it to you guys. Because I was like, why isn't this being calculated? It's such a simple thing to calculate if they would just add a couple of things. So
yeah.
Yeah, I did add some on the bottom on my thing. I added how to calculate the that if the number populated, it will automatically populate the margin of error. So.
Excuse me.
So that one, I plotted plotted that one already here on mine. So what is being asked? Smallest variance of the group of the 6 group.
So they didn't really do this. Interesting. Okay.
I got it onto my Excel. You want me to share that one?
That's okay.
Okay.
Good.
So the smallest variance is 27.208.
You say that again. You kind of broke up for a second.
27.208. Hey guys, quiet.
Okay.
Please, thank you. Let me see. 27.208. Okay.
Sorry, my computer froze up, and so I didn't hear it at all.
You can see it on the screen.
Oh, sweet. Thanks.
So on the next one is asking the maximum largest variance. One of all, because there's like 27, 29, 27, 27.358, 29.484, 27.208, 53.158, 31.011, and 40.724. So the largest one is 53.158. 53.158, yes. So the test for equal variance is satisfied for this data.
Yes, right? True.
Yeah. And then construct a QQ plot for each of the 6 samples. Is there a thing that we can put in the information and just create a QQ plot for it? Or do we have?
If we had that other program, it would. I don't know how we would do it on Excel. Right? I mean,
I think there's another.
And again, if this is something
there's one that, go ahead.
You just broke up again. I'm just saying, if there was a way to, I mean, there's probably one in here under your what do you call it, under the tables, but.
Mm-hmm. Well, there's another one that goes with the on one of the Excel, one of the link, it has a quantitative descriptive statistics. What's in there? Maybe we can try that one.
Just do it on the
variable. It's in one of the
Whatever. I thought we put it on yours.
Yeah.
better look. That doesn't look good. Let me see if I can do a QQ plot. Statistics, yeah. Statistical chart. Mm-hmm. Who's making a racket like that? Bradley, is that you?
I don't think so.
Okay. So, are you there, Sam?
Yep.
Okay. It looks like your picture is frozen.
Oh, I'm still here.
Okay, go read it. Did you take the test for the Harry Potter one?
Mm.
After you read it and then you did take the test? Okay. My class right now, please. Would you guys go out there? Daddy, are you getting? Hey. No, I can't. Silly goose. I have to block the camera for a minute.
Hey.
Hey. You gotta let me know if you're doing something there or not. Sorry. Hey, Bradley, are you still there?
Yeah, just one sec.
Do the QQ plot in the first place. I'll figure out tomorrow how to download that PSP or whatever that is. I know they should give us a. Yeah, what happened there? Blood. Well, they're not. All that numbers are not really into QQ plot thing. They're all scattered. Okay.
So would that just mean it's false?
Let me see. Let me finish.
Like, honestly, I'm not sure on this, but I feel like it's true, but I'm not sure on that.
So, doing all of them quick. Isn't it the QQ plot? Somehow I am having trouble to say that thing. Should be along the line.
I don't know.
And if it's not along the line, that's not a.
You're asking if it was along the line?
Within the line, isn't it? And I'm not getting that. They're all scattered.
Well, a QQ plot, I think it's just asking us if we did it, right? It's not really asking us. Okay, are normally based on what you see. Okay. I don't know how we make the QQ plot. I mean, it shouldn't. I don't think we need to be making these by hand. I don't think they'd expect us to do that.
There's another one on that link, guys. One is called quantitative descriptive statistics. There's a QQ plot box there. The data on the right side or the left side.
All right, I have here a data set. All the way down.
And then.
So I have a data set of.
On which link are you talking about?
The one that we got the Excel that we're using right now.
Right.
another Excel there that's for quantitative descriptive statistics. And histogram there and a QQ plot. Did you find that link? Let me see.
Yeah, send that to me again. Remind me where that's. Is it in our table of contents or somewhere?
Yes, let me double check. So I get my.
I think it'd be in our technology folder or something.
Somewhere. Go back to lesson. I think lesson 12 or 13. There's a link there somewhere.
This really shouldn't be that hard for us to find, you know.
Here.
No.
Let me. Here, I'm sharing it. Just a sec. And it should say descriptive statistics, the first one.
Statistics or procedures? Statistics.
It's the statistics. The first one, unit 1.
Okay. QQ plots. I see. So now they're saying to take this. I see. Okay. So they're saying take this. And I'm sharing my screen if anyone wants to watch. I don't know how exciting it is. But
See, it's all scattered.
yeah. But are they all like this?
Pretty much, they're all like scattered. And there are not normal base then. This is the dots are closer to the line.
Like that?
If that's my understanding.
You see mine?
That's better.
You forgot step 2. It says sort
what
column from lowest to highest number.
Oh, okay.
So once it is, it becomes normal, so it'll be true.
Well, that's just the first one to do all of them. So that's our first one.
Yes.
We'll go through. Do you guys feel that that one's normalized there?
Definitely.
Okay. Well, I'll go through and do them all real quick.
Sort. The number 6 is pretty close too, so.
Number 2 looks kind of hinky, doesn't it?
I don't know. It looks pretty close to being normal to me.
Along towards the top or towards the end is okay, but if it's in between, floating away from the line.
Let's see how the others.
This is another one of those. Oops. This is another one of those. I wish they would be a little bit more specific in what's normal and what's not.
Yeah.
Sorry, I forgot to read the instruction right next to it.
That one looks pretty good. That one looks fine.
That was fine.
I'm on number 5 at the moment.
I think overall they look pretty normal.
Pretty, yeah.
Yeah, so I would definitely mark that one as true.
Yeah. I agree.
That was the last one. Okay.
Okay, that question.
Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data, perform the test again. What's it without? So if we look here, okay, so
The stock is the
p-value,
last one.
I got 0.309.
Yeah, I was about to say that.
Yeah.
And
Wait, let's see.
wouldn't that make for the next for answer 13? Would that make it so?
Ooh, you're becoming like a
well, I can't hear anything.
Gavin.
What was that? On 13?
Wouldn't that make it? Wouldn't it be right if it was at statistic?
I think so.
Yeah, the F statistic is always right.
It's always,
You're
yeah,
right.
it's always right, isn't it?
I think so.
Yeah, that's from what I.
So
From what I know.
there's one. Okay. New.
Okay, so researchers types of hot dogs, beef and poultry and meat. For each of the 54 hot dogs analyzed, they recorded the type of the calories, the sodium level. The data is in this Excel file. Let's examine the calories first. Construct a QQ plots of the calories of each of the 3 types of hot dogs. Compare the variance. Okay. We're doing the
You're
calories.
making us sleepy too.
So we'll start with the beef.
Bless you.
Yeah. Bless you.
Thank you. All right, so this is beef. So pretty normal on that one. What's the question that they're asking us here? The assumptions have been met or not. And then it's safe to assume that they're normally distributed or not. So I'm not sure what we're, besides looking at it, this is normal with QQ plots. What exactly, how exactly else do we?
Let's see.
From what I saw right there, it looks like it's normal. If you read the first one, it says the assumptions have been met. It is safe to assume each group comes from a normal distribution population, and can also assume the variants are equal. So I don't know, based off of what I see right now on your screen,
Well, that's just
A makes sense to me. But
that was just B. So this one will
that was
be,
just B.
that one was just B. So let's do this. Let's now do this one will be why isn't that pasting away? Well, it's all of a sudden.
Some sleepy heads. You guys keep yawning.
Yep.
So that one is the meat. QQ.
Well,
And this one's the poultry. I just feel like we're missing something. I feel like we're supposed to read more than just, oh, it looks near the line. I don't know. Maybe I'm wrong, but
I don't know.
no, because if you know what the QQ plot should look like what is normal. That will be easier to determine whether that's normal within the normal range or not.
Yeah. But do we need to mess with the number or the standard deviation? Does that matter with any of the stuff we're looking at here, or not really?
I think it's just the sample.
Yeah, I think it's just the sample. I don't think standard deviation or anything else has any play in this.
Does anyone want to guess on the answer to this question?
Hold on, let's see.
I personally think it's A, that the assumption has been met, and that all the charts that we have say that the groups come from a normal distribution population. So I would say it also assumes that the variance are equal. So I think it's A, but
I say let's go with it.
For now. First, I'm trying to find a good QQ plot thing.
Mean calculation related to the research one. What conclusion can you draw?
So we're still on number 14, right?
Yep. You know, so how, I guess the first part of this question, what's the assumption, and what do we have to know if it's been met? So do we need to also put this in the ANOVA stuff as well, right now? Or?
Yeah, because it will be asking, I think they will be asking some question about it related to that.
It's asking it the next one, but do we need to have the ANOVA stuff for this one is my question.
No, I think it's just the sample that they're asking. If all the samples have met the standard for.
So it's asking if it's met the assumption. So do we know that? What's the assumption? That's what I'm asking. Do we know what the assumption is?
That's the only thing I'm tripped up on, because I have read the question multiple times and there's like notes, like there's none really made. The only thing it really asks for is to record the type of calories and the sodium levels.
Hold on. Let me share this with you guys. This is what the normal QQ plot should be.
Do we want to just move on to number 14? I mean, number 15, or wait, yeah. Do we want to just move on to number 15C? We can do that one, then come back to 14.
So it's a matter of, yeah, I mean, I guess I just personally do not understand the question, so I don't.
Number 14, let's just leave it that way, number 1 and the first one, and then.
Okay, so run an ANOVA test to determine the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. The F is 16,074, and the P is 0. The level of significance is 5. What conclusion do you draw? Which is, I think, exactly what I got, right? 251, yeah. So what's our conclusion? So it's saying.
bottom, we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than the other type.
I agree.
Because it's below the 0.05, correct?
Yeah.
Cracks me up. So, like, essentially they're just changing the language instead of the rejecting or not rejecting the hypothesis. Now they're just making it a... So that's the last option, correct?
Yeah.
Mm-hmm.
So now we're going to go back in and we're going to have the same problems with sodium levels. So well, should we go back to 14? Does that give us any information for 14?
Is there a sodium level in here? Okay, yeah, there is. Hold on. Let me do that. Oh, yeah, yeah. Copy.
Okay, so I found this in our homework. It says, since the largest variance, s squared, is not 4 times larger than the smallest variance, we can assume the variances are equal. The points in the QQ plots for each of the 3 groups not shown follow the line closely, suggesting that the data can be assumed to be normally distributed. We conclude that the requirements are satisfied and that it is appropriate to use ANOVA. I guess that's kind of talks about the assumption. So I guess it's talking about the variance is not 4 times different. So were any of our variants 4 times different? I don't believe so, right?
Let me see the stuff.
So the assumption should be met, and if the QQ plot is followed, it should be normally distributed. So the assumptions are definitely met because we just use the ANOVA down here just fine, right?
Mm-hmm.
So I think we can eliminate B and D. Now, doesn't this saying that, isn't essentially since P equals 0, doesn't that specifically say that it is not, the variances are not equal? Or is that, am I getting that backwards?
Let me see. Hold on.
Sam, are you still there?
Yeah, I'm still here. I have no idea.
I just,
Hold on, I'm scanning through our textbook. Just a sec.
kind of what I'm looking at, Sam, if you can see that. I don't know.
Yeah, hold on to it. Since the largest variance, we can assume the variance is equal. Is not 4 times larger, we can assume the variance is equal. The points in the QQ plots not shown follow the line closely. Can be assumed to be normally distributed. We conclude the requirements are satisfied and is appropriate. And so what were you saying, that they're not equal?
The only thing that throws me off is, so if we're answering this question saying that we have sufficient evidence to claim that one of the types is different, doesn't that mean that this, or excuse me, well, but the assumption has been met. I guess that's the only one that says this. That's the only thing that's confusing me. Because it's like here we're saying the variances are equal, and then here we're saying that they're not equal. I think.
Yeah, I'm not sure.
This has definitely been the most confusing class I've taken so far.
Yeah, I don't. I'm glad we don't have to do this all on paper. That we can just punch in the numbers into the formulas.
Yeah. Well, that's what I mean. Like on this one, it just seems like the verbiage is ambiguous and confusing. Not really that we don't understand how to put the numbers together.
Yeah.
So why don't we just leave? Hold on, let's see. It's the largest variance. Is larger than the smallest. So they follow the line closely.
Sort of. Again,
Sort of.
I guess it just depends on what closely means. That's what kills me. It's like the example you sent us is like right on the line, and then like this one, that's not close, that's not close, that's not close, and then these are close, so it's like, what's close? Is that
so that means that's not normal.
That's what I'm saying. Is this not normal? Or is that's still normal? Like what, I guess that's what throws me off is it's like the examples they show are smack dab on the line almost. And then this doesn't look smack dab on the line. It looks close.
Yeah, because that's what they said. If the top part or the bottom part wanders away from the line, that's pretty okay for the normal, as long as the middle part are all within the line.
But none of the middle parts in the line. I mean, the edges
Yeah.
are the top and the bottom, then none of the middle is on the line. On this one. That's where I get thrown off.
So that means that's not normal then.
So then this one would be happy to say the assumptions have not been met.
Yeah.
And then it'd be like this it'd have to be this last one. But again, I'm not confident. I'm just trying to talk it out.
Yeah, it's confusing. I don't think I quite grasp the concept.
So there are 4 of us. We can try all it.
Yeah, I mean, I'm going to leave mine on the bottom. I'm going to try that. That's the one I'm going to try. But yeah, we can all.
What number are you?
14. I'm doing D.
Okay.
So somebody needs to do A, B, and C.
You couldn't hear me. I said I have A.
So Gavin A, Dan B. B is in Bravo. Sam Bravo.
14B.
Yeah, and then 15. Do we feel good on 15 though?
Yes, I feel like that one's right.
Yeah, let's go to 16. Now let's examine the sodium levels. Okay, so I will do that really quick. Sodium. Okay, so here's the beef sodium levels. So that one looks a lot more normalish to me, even though it's still not great, perfect, but that looks a little better. And there's a couple jogs here and there. That's beef. I like how they have beef, chicken, and then meat. Like, they're holding.
Is this one talking about variance or?
That's a QQ plot of the ES. Those are the samples.
Okay.
That one looks good, for sure.
That looks pretty close, yeah.
That's the meat, and then poultry. Poultry looks a little wonky, but
yeah.
Again, is that
it's all relative.
Yeah, exactly. It's like, okay, is this chart point? Yeah, I don't know. You want to do the same thing? You guys pick the same Go ahead and pick the same letters for this one, and because I think that's fine because this to help us understand. We can go back and say, okay, this is it, and let's understand why that was it. So I think that's fine.
Okay.
So then I will now do this part of it. Sodium and p-value. Okay.
Despite a possible problem with the QQ plot for poultry, you decided to use.
Okay, so there we are. So p-value is 0.179. 0.179 for 17. What's the conclusion we can draw from the sodium levels of 3 hot dogs if it's A equals 0.05? So the p-value is greater than. So what does that mean again?
That means that we failed to reject, right? So we don't have sufficient evidence.
Yes, we keep it,
I
right?
think it will be B. We don't have significant evidence to reject the claim that all 3 hot dogs types have the same mean sodium levels.
So can you show me the mean?
The p-value?
Can you make it that bigger? It's too small for me to see. Sorry, I'm blind.
You're fine. Is that better?
Yeah, that's better. The variance. The variance are not that bad. So.
Right. Isn't this really just coming down to p-value at this point? P-value versus the alpha?
So, and it's higher than the alpha.
The alpha is 0.05, so this is greater than that. So we're going to fail to reject.
So when we have a higher p-value, that means it's more likely that they are closer together.
Right, so fail to reject means keep. We like the hypothesis. So
let's see, let me think about this. So we had a low p-value, which means they were farther apart before.
So it should be A. It should be A, right? Because it says we have sufficient evidence to claim that all 3 hot dogs are the same mean. Right? Isn't that fail to reject? They say it kind of back.
Textbook, according to here, because the textbook has a 0.019, and that is greater than 0.05.
Yeah.
Greater hypothesis, and then at the bottom it says there is sufficient evidence to suggest that at least one of the 3 group has mean level of satisfaction with life that differs from the other. The mean level of satisfaction with life in general is not the same for all 3.
So if it's greater than, then they're different, is what you're saying.
So let me see what's the thing. We have sufficient. The 3 hot dog type have the same mean. No.
So it'd be the last one.
The sufficient evidence claim that at least one of the hot dog type has a different mean. Yes.
This is why I need to get it automated in the Excel, because I keep messing up which way is which, you know.
At least it's an open book exam. You can go back to that aspect and kind of.
I know, but it's so much easier just to have it tell me what to do.
Well, unfortunately, they want to make our brain work a little bit.
Yeah, I'm going to submit and see where we're at. See if we bond it. 85. So we missed the last one. We
So the
missed
last one?
we missed last one. We missed 16, and we missed 14. So
Go back to the last one. What we answered the last one, isn't it?
I answered the bottom one. So it's not the bottom one.
Okay.
And it's not the bottom one for 14, 16, or 18.
So it's not the bottom one for 14, 16, or 18.
So if somebody else would like to answer those differently and submit, let's just submit one at a time so we're not all doing this.
Okay.
I can do the B's if you want.
I can do the C's and let me submit mine, okay?
Oh, okay, go ahead.
Which one, 14? That's the one that we differ, right?
Yeah,
Have different
14, 16, and 18 are all the ones that were.
C's on that one. Okay, let me submit.
I think 18 is A, I'm guessing, but I don't know. We'll see.
That 14, not C.
Not C, not D. And you did all D's, Bradley?
And
Yeah.
18 is not C.
What about 16, not C?
16, I got that correct. It's C.
16 is C. 16 is
16 is C. Okay.
And then 18 is not C. So
So if Sam, if you could do change your 16.
Sorry, I was.
Oh.
Wait, so what ones were wrong and which ones were right?
16 is Charlie, C. 18 is not C or D, and 14 is not C or D.
Okay, do you want me to try for 14 and 18? Do you want me to try B?
Yes. So Sam's going to do B on 14 and 18.
14 and 18.
Sorry, I lost connection right there. For some reason, my Wi-Fi just went out.
Yeah, one sec, Gavin, one sec.
Okay, 14 is not B.
it's an A.
So 14 is A.
Yep.
And what about 18?
18 is B.
Okay, so
Okay.
I'm gonna submit mine really quick.
So can you guys give us the answer for the other ones? Sorry.
Okay, so I got, after all those, so yeah, I got 100. So do you just want me to go through and tell you the answers for all of them again? Here, let me go into a
Number
quiet
3.
room. Right? My living room's a little bit louder, so let me go into a different room really quick.
I have all.
rooms. Okay, so
3 is
Four.
true, 4 is the bottom 2.
yeah, and then it's construct a QQ plot for each group. And then number 6 is B, the largest variance.
7 is
And
6.
then, yeah, so that's 6. 8 is 27.208.
Hold on, 27 point.
208. And then 9 is 53.158. And then 10 is true.
158.
Oh, sorry, my bad.
10 is true. Okay.
11 is also true. 12 is 0.309. 13 is right.
0309.
So 0.309.
Okay.
If you look at my, oh, you can look at my screen. Never mind.
Yeah, and then it's right. And then 14 is A. 15 is D.
C.
16 is C. 17 is 0.179. 18 is
Say
then
it
B.
again. again?
17 is 0.179.
Okay. 0.1. Okay.
So we need to chat about, when you're done, we need to chat about what 14, 16, and 18 and understand why we get what we have now.
14. So 14 is
14 is kind of what we originally thought, right?
Yeah.
Honestly, I'm completely lost on that one. Like, well, everything else made sense to me, kind of. The only thing that didn't make sense to me was the first thing they said is like the assumption or whatever they were trying to say, if that was correct, because they didn't really tell us anything about that.
The assumption, yeah, that's in the homework. It's in somewhere.
It's in the thing, but
You see, it's like right.
still a little bit.
It's in step 3, but it's hard to understand still. This is all about assumptions in here.
Mm-hmm.
So I
So
think.
is this the only?
What was that?
Is this the only meeting that we're doing for this week? Is it the exam?
Do we have another? Do we have lesson 15 this week?
No, it's an exam. So I think the meeting we have.
We still have lesson 15, don't we? Or is this an exam? No, we still have.
Yeah, there is.
Yep, we still have a lesson 15. Lame.
Why last time we didn't have that? Okay. So
16, I'm not sure about. So let's look. So it's saying you should see that the QQ plot for the poultry suggests a possible problem with normality. The smallest variance is 7,100 and the largest is 10,500. Have the assumptions been met? Assumptions have not been met. It is not safe to assume that each comes from knowledge from the population, but we can assume that the variances are equal. I think, okay, so maybe I do get it. It's saying that the poultry shows a bad QQ plot. So the variances, so it says that they're not normal, but the variances aren't 4 times the smallest, so
Yeah.
they're equal. Am I
Yes.
understanding that right?
that makes sense.
Mm-hmm.
Okay, so that makes sense.
Because if you take the difference, it's not 4 times bigger.
Yeah.
So
And then 18, you do not have sufficient evidence to reject the claim. Both the same. So we just need to remember what that is. So I feel good about it. Anyone else have any questions or want to chat anymore?
I think we're good. So let's just prepare for the Wednesday night
And meet back then.
and then the exam.
All right, guys, have a. So hopefully the lesson 15 is like an exam prep. I don't know. Hopefully.
I think it might
Oh,
be
that'd
an
be really
exam
nice if
prep.
it
Let
was
me
an
check.
exam prep.
Let me check.
That helped me out a ton last time. I hope it is.
No. Lesson 15 in the textbook. Let's see.
Dang it. I was hoping it was an exam
That's
prep.
not. Oh no! Yes, it is. Review for exam 2.
Sweet.
Good. Okay, guys, we'll see you guys on Wednesday night then.
All right, good night.
Yep.
Okay.
See you guys. Have a good
Have a
night.
good night.